Hello, so here's how the verification token logic works in my Node.js applications. All right, so we are going to be using a couple of technologies. Obviously, we're going to be using the Node.js for our server. We're also going to need a Redis cache, and we're going to need some sort of email service that Node.js can use to go ahead and send emails to email accounts, right? So there are many examples that we can use. A notable one is NodeMailer, right? Another one would be SendGrid. That's also a really good one, right? So, it doesn't really matter which one you use. Just make sure you have that sort of service. So here's how it works. We're going to first go to our client, which is this computer, right? That's our front end, back end, database or storage system, and the email account. But anyways, we're gonna first request a password change. Okay, and when we request that password change within the front end, it's going to trigger a token generation. All right, within the back end. So we're sending a request to the back end for now a token generation because we need that in order to make that password change. Now, the reason for this verification token and all this architecture that I've built is so that we can verify that the user is who they claim to be because they have no way of logging in now, right? And that's simply because of the fact that they are logged out of their account and they want to reset their password because they forgot their password. So how do we verify that, hey, this is the person who owns the account? Well, we can do that with the email because presumably if they put in an email to register an account, it has to be their email. They have to have access to it. So to verify that this is their email and therefore this is their account, we can just go ahead and send a verification token to that email. All right, and if the verification token that they give back is correct, and we'll see how we can validate that, they're good to go. But anyways, that's the whole reason for verification tokens. But now this is our first step. It goes ahead and goes into our Node.js server, and then a token is generated. And it's generated with the crypto library. So you can go ahead and do npm crypto. Right, I misspelled it, but whatever. It's this library over here. This library allows for a lot of this one. That one's deprecated. This one, Crypto.js library. All right, and this allows for a lot of encryption algorithms. As you can see, these are SHA256. This one and this one. They're all different encryption algorithms. All right. So anyways, now that we know that we are sending a payload of the email that the user has supposedly given, right, that that the email is associated with, right, it is put into the token as payload and it's encrypted so that it adds that extra security layer for any person who might want to tamper with it. Now then it's saved within the Redis. So this is where the Redis comes in. This token is saved within the Redis, and you'll see in a reason in a moment why we need to do that. All right. But now an important thing to note is that it's not saved with the regular .set method, but a .setex method. And this allows us to actually set an expiry time within that key value pair, because remember Redis stores key value pairs. So it just lets us go ahead and set a specific timing in which that key value pair will be destroyed or deleted from that Redis cache and therefore expired. So that way all the expiry functionality is being taken care of by Redis. All right, so we can set that expiry time within the setex method to any time we want. Right, I personally like to keep 15 minutes. That's like the sweet spot. But yeah, all right. So there you go. We added that expiration functionality through Redis, and now we saved that token through Redis. Once this is done, we are going to also send this token via email through the email providers that I talked about earlier in this video to that specific email that the user has said that they supposedly own. All right. So make sure that we first store it within the Redis database, the token, then we send it. All right. We don't want to send it first and then save it in the token because what if there's some errors within the Redis cache? All right. And so then we have a token which doesn't really do anything because with our validation logic, we're actually going to be cross-referencing with the Redis database, which is what we're going to be talking about now. All right, so now the user has this token through email. They can go to their email account, get that token. So now we're going to go right back to the user, and you're going to see that they now have the user token. All right, so then they'll send it back to the server with a new request for verification. So Node.js will go ahead and verify through this. It will go ahead and take the token, all right, and they will put it into Redis DB. Okay. So basically, what's happening is the token that the user has gotten from the email, they give it to Node.js through payload, right, through request.body, and Node.js will send that token to Redis through a get command. All right. Now, if it is found, we're good to go and we can move on to the next steps. If it's not, we already know that token is invalid because it's not found in the Redis. And that could be because it got deleted due to the expiry time being reached or whatever it may be. But anyways, once it is found, there's actually another process that must be done. All right. So in this case, we're going ahead and requesting it, and once we get it back, we're gonna go ahead and do this process. So this process happens only if the token is found within the Redis cache, and if it is found, this is what's gonna happen. So we're now going to verify it through the payload. So this is why we needed the payload of the email. All right, and we're simply going to decrypt that email payload, right, with a reference to the account that the user wants to go ahead and change the password with, right? Because with both of these requests, we're gonna ask for a payload of email, right? What email is this account associated with? So within this payload, we're going to get that payload of that email that we want from the user, and we're just going to cross-reference it with the token. If both match, that means that this user has to be the account owner because they got that token through their email account, which can only be accessed by them, right? So if that is done, we just go ahead and verify their identity. And then after this, we can go ahead and do whatever we want with the verification token. In this case, resetting the password. All right. So that is my whole logic. It's pretty sound, I believe, and it's pretty good to go, especially with using Redis instead of like a traditional database. Because I'm anyways already using Redis for my session management, so might as well use it for my verification token. And this is just because it's really fast, and again, it's a cache, so it's meant to store temporary data, right? And this token is temporary data. It's going to go away eventually. So I don't see the point in using my database to do it, right? When it's going to be temporary, and it will just cause a lot of read and write issues, especially with the database. That's going to cause a lot of latency issues and performance issues, which I do not want for my application. So that's my whole reasoning of using Redis instead of a traditional DB like Postgres. All right, that's it from me. I hope this helped you. Maybe you might want to go ahead and copy this infrastructure. If you do, link to this Google drawing, I guess, is in the description below, so you can go ahead and follow along without having to listen to me yap for like 9 minutes straight. But anyways, take care. Bye.